Hello, hello. Good morning, good afternoon, good evening, everyone. Welcome on the Learn Grasshopper live session. We are continuing series with about Tekla, how to use Grasshopper in Tekla structures. And today we are going to extend that and we are going to add one new amazing software, idea StatiCa, and we have the best expert about connection, idea StatiCa and Grasshopper, the creator of the connection between these two software, Nathan. Hello, Nathan.
Hey Chris, how you going? Good to be back.
Yeah, for those who haven't seen the last series last year, Nathan was my guest and we presented connection, Grasshopper, and idea. And today we are extending that and we are adding Tekla. So you're becoming Tekla experts, Nathan, right now?
Yeah, exactly. Trying to connect the two bits of software, obviously, Idea Statica from a connection design point of view, and Tekla being, I guess, one of the primary software for detailing. We're definitely always trying to look for better connections with Tekla, and hopefully can show you some of the stuff we have available and what we're working on today. So yeah.
That's cool. And for you are normally based in Australia, but now you're visiting Europe, right? Where are you based right now?
I'm in Brno, Czech Republic, so in the headquarters of Idea Statica. But yeah, usually based in Melbourne, Australia. So big trip on the weekend to get here. Um, so we'll have our partner summit next week, and I think you'll be there as well, Chris. So that'll be good to finally meet you in person.
Yes, I'm going to be in Vienna as well, and this is also the reason why we are meeting a little bit earlier than usual. Usually we have at 2 p.m., so now at 11 because maybe after jet lag, Nathan was going to sleep at the 2 p.m. So
Exactly.
that's why we are meeting. Hello everyone, we have lots of people here. Hello Tobias, hello Adam. Just write in the chat. We are starting in just 2 minutes. If you are using Tekla or Idea Statica, or maybe you are using both of them. So hello Maestri, nice to see you. Good to see all of you. Maybe some of your friends. Again, we have some people from Norway, from Poland, from Czech Republic as well. So just write on the chat if you are watching that. If you are a Tekla user, or if you are Idea Statica user, today this two software we are going to talk most of the time. All right, on my clock is already 11 o'clock, so let's get started. I see your answers already coming. So as always, we are live on Facebook, LinkedIn, and YouTube. So I will really appreciate if you could leave a like, subscribe to our channel to reach more people and promote computational design of working. So today session will be 1.5 hours. So we are focusing on 60 minutes of presentation, and then it will be Q&A session. So recordings will be available to watch later, as always, for those who register on learngrasshopper.com Tekla-connections. So we are going to send all the recordings and also Grasshopper files, or the videos that Nathan is going to present with Grasshopper scripts. We are going to share so you can try for your self. Maybe we can also already say which version of the Idea Statica are you going to use, Nathan?
We're going to use version 25, so the most recent release, basically available.
And test you made also on Tekla 2025, am I right?
2024 I was
24.
using with
24.
Tekla.
Yeah. But it's I have tested that on 25 and it's working fine. So there is no big changes to that one. And as always, this workshop that we are having, these workshops are for you. So I'm reading all your view comments. So if you're going to have any questions to me, to Nathan, to Idea Statica, to Tekla, or Karamba, we're going to show Karamba. So please let us know on the chat. So two important things. We are going to show the connection between Idea Statica, Grasshopper, and Karamba, how to make this automation in the connection design. And as I said, we are going to share all the Grasshopper files. So this is the Tekla webinar, Tekla series in 2025. We started with Oscar. He talked about how to automate prefabrication design. We had Joel. He talked about how to automate rebar drawings in Tekla with Grasshopper. And last week we have guests from Trimble. We have Gabriel, Sebastian from Trimble, and Greg, who created Grasshopper Tekla drawing link, and we showed the total parametric workflow for bridge design. For those who are not familiar with me, seeing me for the first time, my name is Chris. I'm an online educator. I'm trying to transform engineering work into fun with use of programming. So I have created my own learning platform, and I'm teaching engineers how to have much more fun at work. Last year, we have created a comprehensive training called Tekla Learn Grasshopper in Tekla. So it contains 2 trainings, live link and drawing link. So we have already more than 200 users are studying with us. We have a huge community where we are teaching how to automate repetitive work in Tekla structures. For those who are interested in joining 2nd edition, you can go to grasshopperintekla.com and save your spot because we are going to start recruitment in 2 weeks. All right, so that was it. For those who are interested in our first webinar that we had with Nathan, let me see, it was in January 2024, so it was already 1.5 years ago. There we focused on the basics, on how to integrate IDEA, StatiCa, and Grasshopper. Maybe I will also paste the link so we can save it for later on. But now, as I said, we are going to a little bit more advanced things. We are going to connect Karamba, which is a structure analysis plugin to Grasshopper, where you can calculate forces in your structure. We are going to talk about Tekla, how to can send information about connection, about beams, and then we are going to send this information back and forth to IDEA StatiCa. So Nathan, welcome you again. If you can share your screen, make it bigger so we can see on the full size. So we can start, so you can make an introduction. I know that you have some news about updates about IDEA because the new version just been released, right?
Yeah, exactly. We've just released our new version 25 with lots of enhancements, and I'll show a video on that as well. So yeah, my name's as you know, my name's Nathan, and I hope this presentation can be as good as some of the other ones that have been on the Tekla in the past couple of weeks. But yeah, so myself, I'm a structural engineer background. So I've worked at companies such as Oricon and Bureau Happold in the UK as a structural engineer. And then have been working in software basically the last 6 years, working at Geometry Gym. Now have been working at IDEA StatiCa for 3.5 years in the software and product development side of things. So BIM and API product specialist at IDEA StatiCa. And recently I've also started basically my own consulting business as well. So helping companies develop workflows like this for their software that they're using, mainly around structural engineering and detailing, and some of the stuff I'll show you today. So feel free to connect with me on LinkedIn after this presentation, or yeah, anytime. Always looking to talk to new people and see what you guys are up to in the industry. So yeah, some of the things basically I want to, I'll talk a little bit about the new release, and then I'm going to dive into some of the IDEA StatiCa Tekla workflows that we kind of have available. I'll show you one without Grasshopper and then two with Grasshopper. So it is learn Grasshopper, but it's always good to know what else is available and the sort of standard, outside of Grasshopper workflows that we have available. And then, yeah, obviously the Q&A at the end. So, so to get started, if you don't know too much about Idea Statica, I'm going to show a video which basically highlights our version 25 updates, and I think it actually really gives a good gives you a good idea on some of the new features and some of the things that Idea actually can do. And we're not just about connection design now as well, so we're pushing into some really complex concrete 3D concrete types of applications as well. But without further ado, I'm just going to play this video. It's not my voice, but you may have seen this one, but I'll play it. It goes for about 3.5 minutes. So.
I'm excited to announce that Idea Statica 25.0 is live. Need a custom anchoring block with notches, openings, or extensions? You can now easily cut and shape concrete volumes for pedestals or custom foundations to match your design. Add casting plates with U-shaped, hooked, or straight bars to your model with just a few clicks. Fasteners, reinforcement, and geometry, all handled intuitively. No one wants to wait for models to converge. That's why 25.0 brings a 5 to 10 times speed increase in 3D model analysis based on complexity. Plus, all of this is now fully localized for ACI as well. Build standard connections in 3 steps with over 200 parametric templates, complete with real-time 3D preview and geometry validation. Parametric templates include input validation, making it easy to stay safe while designing quickly. Restrictive fields help guide best practices, even for new users. Need more control? You can add custom operations for non-standard details. Plus, build a company-specific set of predefined templates, standardizing your best practices with reusable, validated designs. No more repeating configs for every group node. Set once, apply everywhere. Checkbot now auto-groups connections driven by a single reference connection that defines the model type, bearing member and settings. From a possible 1,000 load combinations, Checkbot identifies critical few, saving dramatically on compute time. Plus, you do not need to wait for these results to finish calculating, because you can continue modeling your other connection groups while Checkbot is computing the first batch. Get brief or detailed reports for all connections in one click, with all results in a single PDF. All precast checks are now available, including lateral torsional buckling with construction stage effects. And if your members have openings, you can export tendons and reinforcement from beam to detail and run full checks without remodeling. No more repeating manual inputs. Custom shapes now work like standard library sections. Just create your own cross-section geometry, save it to the project database, and reuse it across any Idea Statica steel application. Apply slotted holes across all specific plates with full control over slot placement. The bolt logic not only reflects real sliding behavior, but reports also include clearer visuals plus intuitive naming. You can now share any connection model, including information about concrete blocks and fasteners, via a viewer link. Viewer loads in under half a second, even for complex files. 25.0 fully supports ACI 31819 across concrete, including pre-stressing, and steel with terminology localized for US, Gulf, and APAC markets. We've added the Australian code in detail, enabling local engineers to work in 2D in regionally compliant formats and nomenclature. With Idea Statica 25.0, your design workflows are faster, more scalable, and region-ready. Stop guessing, start validating, and calculate yesterday's estimates.
I am surprised that it was not your voice.
Oh, sorry.
get intro. And we have some question. Is it possible for cooperation between Tekla 2020 and IDEA 2025? I think it's not an issue. Nathan is going to show the workflow that I think it suits all of the Tekla version, but we're going to show that later on.
Yeah, I think if we will show some of the workflows. If the Grasshopper link, I'm not sure if it was available in 2020.
Yeah, it was.
It was.
Yeah.
So if those components were available in 2020, then it should work. Some of the stuff that I'm going to show. Yeah. So thanks for listening to that. The release video. If you haven't seen it, I think it does show some of the good new features and sort of highlights that we are really trying to push some of these really things that you know in the past were didn't have full control over or making a lot of assumptions. We're starting to push these types of workflows as well as automation in grouping and stuff like that. And then I just wanted to also highlight we have a current campaign which started a couple of days ago, and basically it's opening up Idea Statica to you know, if you already had an existing trial license, you automatically get access to Idea Statica again. You don't have to do anything, and also all customers with active maintenance will get unlimited licenses over that period as well. So basically, if you're a company that has Idea Statica with active maintenance, you shouldn't be everyone in that company can use Idea Statica. You'll get basically unlimited licenses for this period. Yeah, if you want to learn more about that, you can click on that link below. So let's get into it. Idea Statica connection, which I'll mainly be talking about, and some of the possibilities with Tekla structures. So I kind of want to just I'm going to sort of present three workflows. The first one being, I guess, our standard workflow. And this workflow is typically when you're starting modeling in Tekla, and you want to take that Tekla model and use Idea Statica for connection design. I say 80% there. I'd say this is like our standard workflow, and I'm going to sort of I'll touch on that. And then the other two where we're going to use Grasshopper, basically a proof of concept that we have sort of started looking at to connect Tekla components with Idea Statica parametric templates. So you saw a little bit about the parametric templates in that video. We'll discuss a workflow that we've put together for that. And then the third approach is where you will basically define all geometry in Grasshopper and then basically push that to Tekla from Grasshopper and then push that to Idea Statica from Grasshopper as well. So sort of the more standard Grasshopper approach where you're using it as a data hub or whatever for your models. Yeah, so I won't talk a lot about this, but basically our standard product for linking with Tekla is Checkbot, and you saw that briefly in that video as well. Basically allowing you to import the Tekla model that's been created and take the plates, bolts, and welds and create Idea Statica connection files from that. So I have a brief video on this as well, which I'll show. I'll talk over the top of this. So basically the process is you've detailed the model in Tekla, and we have Checkbot, which we basically launch from Tekla. You create a project, and then within Checkbot you can click import, and then you basically get the selection in Tekla. And you can bring that model into Checkbot. So you can see the two connections, and then you can open that connection in Checkbot, and you can see all the plates, bolts, and welds automatically have come in. And here we can basically add some load effects from Excel or from our FEA analysis model to calculate that connection. within a couple of minutes, we can take that Tekla model, bring it into IdeaStatica connection, and do the full design or code checks and analysis within IdeaStatica connection. What it also does is, if the Tekla model say changes, etc., then we can also sync with that as well. So yeah, not using Grasshopper here, but basically like a standardized methodology framework for importing from Tekla, and then obviously you get the connection application itself provides your reports and etc. Yeah, so as I was mentioning, basically if we change that Tekla model now, say for instance we create or have a change the beam size or cross section size, we can, and obviously Tekla is adapting for those cross section changes as well. We can open Checkbot, and Checkbot basically is a real-time connection. So you can work in Tekla and Checkbot at the same time, and you can see here as well, if we've defined those connections, then they automatically get updated as well from Tekla. So it's a pretty smooth workflow if you are basically starting in Tekla and wanting to design connections from that. So and yeah, so basically in the past we weren't able to import anchors from Tekla macros, but we, in the most recent version, 2025, and 2024 as well, I believe, we now can import anchor blocks and anchors in connection components as well. And just on the Checkbot side, this is basically, Checkbot is our standardized approach for CAD and FEA. And we have this approach for basically 25 plus. I think maybe last year when I did this presentation, it might have been 20. Now, within the last year, we've added a whole bunch more links developed by third parties, and it's the same workflow for all of these links. So when I look at the CAD software that we've got available, it's a similar workflow with SDS2, Revit, Advanced Steel, BoCAD as well, and Protosteel as well. So a similar workflow we have available for all these CAD applications.
One more question. Is it any connection between IDEA and Focus construction?
That's a good question. Not that I know of, not that I've heard of, but basically it's quite easy for third parties to develop these BIM links. So most of the BIM links that are being created now, we're not developing them and we're not maintaining them. So if KP knows someone at Focus, then he can get them to get in contact with us, and we can provide the necessary information on how they can create a BIM link with Checkbot and with IdeaStatica.
Yeah. And Martin asked, does the Tekla IDEA link works across different computers?
No, not at the moment. So basically it's a direct link on the desktop. So you would have to have Tekla installed. You have to have Tekla and IdeaStatica installed on the same computer, basically, to get that link to work.
Yeah, that's okay. So just the previous slide you showed, like this bot system, right? The BIM integrations.
Yeah. Yep.
Yeah. Mm-hmm.
Yeah. So it's the basic workflow here. So some of the links IdeaStatica maintains, and we provide the installation for those when you install. And then some are obviously automatically installed with third-party applications as well. But the workflow is the same. You run Checkbot typically from the application, and you have two applications running side by side. So kind of sort of like a Rhino inside type thing. You basically have a direct link through an API, and you can work in both applications at once, transferring data basically um, from the base application or from the FEA or CAD application.
Yeah, Christopher has a good question. In this default workflow, is the changes made in IDEA after checking pushed back to update the model in Tekla?
Yeah, not at the moment in the checkbot workflow. So at the moment, it's using the base application as a as the, I guess, a source of truth for the data, and then we pull that into checkbot, and then if we do the design, it's kind of up to the user to change that. You change that in Tekla at the moment. One of the workflows I'll show though in Grasshopper today will kind of show you how you can push some information back to Tekla though.
Yeah, this is this 20% that you can make advanced and go over a chatbot. Okay.
Yeah, exactly. Cool. Yeah. So since we last spoke, nearly a year and a half ago, we have made some enhancements in our back end basically. So we have released a new connection API, which is based on REST technology, and with that we actually have also released a new Grasshopper plugin. So new API, basically it's a native REST API. So we have IDEA StatiCa provides clients for both Python and C#, but obviously it's REST, so you can basically create your own clients using any software program language that you would like. And then we have built the new Grasshopper plugin on top of that. And with that came some enhancements. So, for example, now we can put multiple connections into an IdeaCon file. In the past, it was you had to create separate IdeaCon files, and I'll show that today.
And in my opinion, it's one of the biggest changes, and it's really like a game changing with this multiple. Instead of having just one file, like several files, you have everything in one file. It's really changes how this workflow is going, like not just switching the files, but inside the program. So this is really, I appreciate that.
Exactly. Like the previous version, basically there was lots of IO operations that we had to do in the Grasshopper plugin to get it kind of working with Grasshopper. But this kind of allows us to have, I guess, one project where we can pass that between components to make it a bit more efficient in the way that it's working. So we now have export IFC in the API and also in Grasshopper. So if you're using IFC based plugins like Geometry Gym or you have your own IFC reader, you can basically get connection geometry from using IFC, and that can also be another way to put geometry back into CAD applications as well. We've slightly improved our template application workflow. We also have ability to define pins and anchors now. So obviously Grasshopper in its geometric engine using connections with pins and complex connections, probably something you might lean towards using Grasshopper where you've got curved plates and stuff like that. So that's available now in our IOM components. And one of the things with the old plugin, it was just using the latest installed version to run the API. You can kind of set that version now pretty easily. And we'll go through a little bit of this stuff as we look at some of the workflows. If you're wanting to download the latest version, and we will release a new version after this webinar. But just go through the package manager, type in IDEA StatiCa, and you can download it. Comes with a bunch of examples as well. in the installation folder. And the one that we'll release later today, tomorrow, is a multi-targeted. So Tekla uses .NET framework in Rhino, but a lot of the other plugins use .NET Core. So our plugin is multi-targeted, so you can use it with any of those frameworks in Rhino 8. So that's so that will be helpful.
I would like to add one more, because we had a question: what is Grasshopper, kind of programming language or just an app? So yeah, just a short introduction to Grasshopper. Is a visual programming that runs inside Rhino application. So it's easier to start and learn than Python and C#, because everything is based on blocks and components. And you can see right now what Nathan is showing. This is kind of components that he has created. And we, as a Grasshopper users, we are using these blocks, the work that he was doing, and we have to just connect it in just right order. And yeah, just. Maybe it's not just, because like Tobias just wrote, I saw the connection with idea, and I must admit it's not easy to start. So yeah, this is lots of new components, but yeah, Rome was not built in one day. So, and what we can see right now, Nathan.
Yeah, so this is just a basic slide highlighting some of the functionality of the Grasshopper plugin. Some of the stuff we'll go through. So basically, the plugin is broken up into two separate parts. The first one is the IDEA open model components, and these are components which basically allow creation of our structural model. So these components, you actually don't need a license of IDEA StatiCa to use. It's an open source model, and these components basically allow you to create this model within Grasshopper that you can then import into IDEA StatiCa. So the big thing with this is it holds the geometric conversion between our model and Rhino. So that's how you can view the plates and bolts and welds within Rhino and Grasshopper, and we'll be showing some of this. And what it also allows is some conversion and conversion of SAF, the SAF file format. So SAF is another open source industry format for transferring structural analysis model data. And we use that in Grasshopper to transfer incoming models from SAF into our structural model format. So we can modify and use that. We'll talk a lot about that today, SAF, or how SAF is used in these workflows. And then the second part is the components which link directly with our API. So for instance, if you have a connection file, how can we use an API to basically perform modifications on that using or in an automated fashion, basically. So you can open files, you can modify them, you can apply templates, modify parameters, etc., run calculations and get results without opening the connection app, basically. So this one you need a license for, obviously, because you're running the application. But they're two distinct sort of modules within Grasshopper.
But IDEA StatiCa plugin itself to Grasshopper, it's free, right?
Yes, yeah, exactly. So the plugin itself is free. When you install the plugin, you'll see all these components, and we automatically, you'll get told whether, if you can't connect to the API because you don't have a license, then the component simply won't work, whereas the other components will work because they don't rely on the application or a license for the application, basically. But you can see all the components when you install the application or with the plugin, basically. And just to let people know who are on the call, we are actually also working on an RCS plugin. So we also have a REST API for RCS, which is our reinforced concrete section application. Yeah, so we are working on that at the moment. So that would allow you to basically import, very complex reinforced cross sections, and do a similar thing what you can do with the connection API. Transfer that into an RCS file, run the calculation, perform modifications, do some automations on reinforced concrete sections. So not available at the moment, but it's coming soon. Just to get excited. If you're interested in this, then let us know.
I'm interested, so I'm letting you know.
Okay, good.
Already when you showed me that yesterday, so I already had in mind how it can be connected with Tekla. So maybe next workshop will be next year about the reinforcement, because this can be also like importing and exporting some cross section from columns, some walls, and going to IDEA with Grasshopper. That can be cool as well. But yeah,
Yeah,
maybe the next one.
Yeah, exactly. Even taking like reinforcing from Tekla, etc. It's we can have a look at all that sort of stuff. So yeah, this is exciting. This is being developed by one of our other software engineers for his thesis at the moment. So hopefully this will be available soon. Okay, cool. So should we start talking a little bit about Grasshopper, I guess, and showing some examples. So yeah, so both of I'm going to show two examples as I sort of discussed before, and both of these examples are going to use Karamba, which is, as Chris said, an application or an FEA analysis app that's built within Grasshopper, and then we're going to transfer that to IDEA StatiCa and Tekla. The two examples are kind of follow this logic. One of them basically is going to be creating the, I guess, the plates and the welds and the bolts explicitly in Grasshopper. And one of them is going to be more of using the template application approach, which is available as well. So when you think of components in Tekla and parametric templates in IDEA StatiCa, we're talking about the template application. So when would you use one or either of these approaches? Typically when you have a structure which is has sort of a pattern, but has very, I guess, complex geometry, and it's hard for, I guess, a template to know where a plate should be placed in space. You might want to look for an explicit component geometry, because that's where we might want to use Grasshopper to perform some of those geometric calculations for us to get more precise geometry positioning, etc. Also in explicit component connection or these complex connections, you might have like differing member sizes, etc. But similar-ish logic that can be used to create these connections. So Grasshopper is obviously very good at logic. So you can use that to perform or automatically generate plates and welds and cuts and etc. like that. Template application is generally good where you have like the same number of members and just slight geometry modifications within those members, and also loading. So just a brief overview in like when you may want to use some of these different approaches. So as I mentioned, both of the examples I'll show are going to use start off using a similar approach. They'll take a Karamba 3D model and we'll convert that model to SAF, and then we'll use then we'll convert the SAF model that has been provided into IOM. From then we'll create the Tekla model from our IOM model. And don't worry if this is seeming a little bit too ridiculous. It will make sense when we have a look at the examples.
And I just want to add that Karamba 3D you can download for free in the package manager as Nathan showed with IDEA StatiCa. So you can download Karamba, And they have also available for free this engine until some number of elements. So
Yeah,
I think
20 or something.
our 20 example. So I think this example that Nathan is going, the first example going to show, it's up to 20 and up to 20 members. So you can use the free license of Karamba.
Yeah, exactly. Okay, yeah. So the first example I'm going to show, and I'm just going to just give a quick brief overview before I jump into it. But basically, what in overall, what we're going to try and do is we're going to take a Tekla component, and we're going to match that with an Idea Statica parametric template. And the idea is that we want to basically link these two things together using Grasshopper. So we can basically pass information between the two within Grasshopper, basically. So why would you want to do this as a way? So basically, Idea Statica now we have a huge number of parametric templates, and you can also create your own from scratch. And you can also take an existing one we have, and it's very similar to, say, how Tekla works with components as well. Obviously, Tekla Structures has a huge number of components, and in a lot of cases, users are basically exclusively using these. So there is benefits in enabling linking between these two. So basically, it reduces, I guess, the amount of data that you have to send. So you're not actually sending geometric data. You're just passing parameters between the two. So reduced data transfer and provides a sort of a two-way mechanism. But there is sort of some warnings as well with this approach. You obviously need to make sure that you have linked them correctly, and you need to make sure that your models are consistent, or else you'll end up with your design not matching your Tekla model. And obviously, to set these things up, it does require a bit more of a time outlay. So
I wanted to just add to this workflow, but what I really like that you are not limited to which component you are using, because basically your company maybe have created your own components that are not standard in Tekla. So basically, you can use this workflow for every single component that you have created in Tekla. It's just about connecting the parameters. So you're not limited to specific components. And this is, I think, the most powerful thing about using this workflow.
yeah, exactly. It is expandable, so you can expand it as much as how much ever time you have, and however you want. So, yeah. So the main problem that we have to get around when we're looking at Idea Statica and Tekla, Idea Statica, when you're designing a connection, it basically has one list of operations, and that is your connection, and one list of members, basically. So we don't have the ability at the moment to basically split these into components as Tekla does. So obviously in Tekla, you have a component which you connect two elements to, but there may be, say, three components within one Idea Statica node. So we kind of have to get around that. So that's an interesting point, and we'll use Grasshopper as a way to help us do that. So basically, the workflow is when we have a connection point in Idea Static or in Grasshopper from Idea, we'll assign a template to that we've created, and then we'll use some new components or some sort of proof of concept components that we've created to output what I'm calling a connectivity map between Idea Statica and Tekla. And then from there, we'll basically have a parameter mapping that basically maps parameters in our Idea Statica connection with component parameters. And this parameter mapping allows a convert to and a convert from. So we can either go from Tekla to Idea or Idea to Tekla. And this parameter mapping also needs to handle obviously units between the softwares as well. So I think it's probably worth starting and jumping in. So this is a video. I'm just going to, so I'll push play on this. And this, hopefully, for the people who haven't seen Grasshopper and Rhino before, this, and Karamba, obviously, this will help as well. So basically here I'm using Karamba, and you can see that I can actually, I've got a model that I've defined, and within Grasshopper I can basically view the analysis model, view results, and I have all that information within Grasshopper. And then as we kind of learned, Karamba 3D has a SAF file output, and we can export that model with results with results and model to our SAF file, which is it's actually an XL file if you're not familiar with SAF. And then going to the IdeaStatica components, we can convert that SAF model to an IOM model.
But important to add that it's not just for Karamba, this workflow. So it can be lots of different software that you are using right now. So Karamba is just a showing idea, and it was easiest to show on this example.
Exactly. So there is a lot of software that exports SAF. So you can use this workflow with any software that supports SAF, basically. So here now you can see that I've basically converted our IOM beams to Tekla, and we've got the beams coming into Tekla. And what we do now is we basically create a map between the Tekla model and our IdeaStatica model. So so that means that I can take information that I have in our IOM model, and I can link it together with Tekla. So in Karamba, I've created basically a couple of groups. So we have a group for the column, the main beam, and the secondary beam. And that's allowed me to do some really basic connection grouping. So you can sort of see that, the connection types there, and then to the right, the assigned templates. And within the folder here, I've basically got a bunch of IdeaStatica templates which I've created, which I assign to each of those grouped connections. And you can see here that we've in the tools, we've added a couple of different components. The template mapper being the main one that maps the connectivity between these. So you can see in this, and this just takes like a JSON file. It takes the primary group, which would be like the primary part in Tekla, and it will understand how many Tekla components should be in a connection. So you can see the output here, the different details, and then also the IdeaStatica ID members, which it should match to. So that's basically doing the connectivity, which we talked about, mapping those three components to one IdeaStatica component, one IdeaStatica template. So in here now, basically I can use a Tekla add component component.
Component. Yeah, component.
To add them to Tekla. So you can see here, it's added, I guess, the basic values, and I'm setting the attribute file to like a default one that I've created, which makes sure that the values that I want to change in IdeaStatica, such as like the stiffener thicknesses, or this bottom plate thickness and width and height, will come through in Grasshopper. That was the best way I found to get them to come into Grasshopper. So basically, yeah, so once you've applied those components, you can get the attributes that are assigned. And then we have these parameter mappings. So you can see here in this folder, I have a mapping for each component, and basically it takes the source key, which is the attribute key in Tekla, the idea key, and then also provides a converter. So if for each one, we're just working with lengths here basically. So it will convert the length from Tekla, which uses millimeters, to idea statica, which uses basic SI units. So you can sort of see here, once I pass it through that Tekla to idea component, you can see the attributes were input get converted to idea the idea parameters, which that is linked to. So just looking at the template for this central knee connection, you can see the parameter ID, and I've used some denoters 1, 2, and 3 to represent the different template or the different components in this template. That's something we will look to try and improve or improve this workflow in the future. So now we basically have our components with our parameters mapped to our idea parameters. And now what we need to do is create the idea connection. So we're going to use the connection API for that. And this is the new API or new plugin. And what we can do, or what we have to do first, is run or launch the API. So we can use a runner component for that. It basically starts the API in the background, and then we can, from that, once we do that once, all the connection components will get access to the API. And here we create that idea statica project from our IOM, and you can see that it's created 6 connections in that project, and they basically relate to the connections which we've provided a template for. So if we haven't provided a template, we're not going to worry about creating them, because we just want to focus on the ones that we have applied a template. Again, using the API components, we can apply that template that we assigned to a connection. And then once that template is applied, we can extract the parameters. And after we have done our mapping, we can basically take the Tekla attribute values and then push them into idea statica. So then basically we'll have an idea statica connection file, which will have matching values to our Tekla model. And why do we want to do that? We want to do that so we basically have our default values that we may have set up in Tekla to be able to start the design process as well. So what we've done there is we've pushed those Tekla components into the connection, and then all we need to do now is save the project, because now the API is a REST API, so that connection project is actually in the server. And once we've saved it, we can open it, and you can see that the template has been applied. And if you click on the operations, you can actually see the parameters that are matching the ones from Tekla. And similar thing with the base plates as well. Even grout thickness basically has been mapped in this instance as well. So we want to now obviously use idea statica to design the connections, and you can see that the load effects have come through from Karamba as well. So we'll basically test the first our default values from Tekla, and we can sort of see that our welds aren't working here. So we might want to change some values basically. So so maybe I'll just change the end plate thickness to 16. Rib, and they just change these ribs to try and take some load off these welds, etc. So I can do that. I can rerun the calculation. Make sure it's working. So it's all working now. So basically, what I want to do is I want to save this to sort of say these are the parameters which make this connection work. So I'll just save this as a new file here, and this means I can use the idea statica connection file as basically the way that I update the parameters, because trying to update in Grasshopper when you have multiple connections with multiple parameters can be a little bit difficult. So using the IdeaStatica connection file as a way to hold those design parameters is what we found is a relatively good approach. And then simply we can open that project that we've saved as with the correct parameters, and then we can basically start to deconstruct. Again, we get the parameters that were in that particular file. We need to do a little bit of Grasshopper magic to get the tree structures correct.
But Nathan just made it all for you, so you don't have to create it from scratch. So
exactly, you can copy and paste this if you want. And then we have our idea to Tekla component, which basically again takes the idea keys and idea values, converts those to the Tekla representations, and then obviously Tekla has the set UDAs component as well. So yeah, with this one, I found that I had to open the component to apply the changes. I think there's probably a little trick that Christoph can tell me to fix this, but you can actually see that the values for the end plate have been updated based on the IdeaStatica model, and you can see that the haunches have been updated as well. And then you can also see that one of the some of the other parameters that we haven't linked correctly because we don't get that. We get a little offset as well, but that means that we need to like modify our mapping file or something like that. So that's kind of basically the first workflow that I wanted to demonstrate. As I said, it's a proof of concept. These things are kind of the components and stuff like that have been developed to sort of demonstrate this. But definitely keen to hear if this is something that you're interested in, and this is probably something that we would look to implement into our more standardized approach if we could make it happen.
I think it's like this really important. Like if you can just show one more time, maybe this JSON file, because this is maybe we can show and explain a little bit more that this is just a text file.
Yeah.
Maybe you have it open, so like you can create it by yourself, just writing in the text file, and this is where all the magic happens between connecting the correct attribute in Tekla with correct template from parametric template from IdeaStatica, and you can create it by yourself, just changing this text file.
Exactly. So yeah. So this component, or the parameter component, basically looks at this directory and it loads in every mapping that you have. So all you need to do if you wanted to add another one, you could just copy and paste this, and then you just add the mapping for that particular component. If I open it, I can. Just 1 second. Yeah, so each of these files is very simple. You just sort of copy and paste this. It's a JSON file, and then map, and then provide the idea key and then the source key. So there's actually nothing really you have to do in terms of changing the Grasshopper script or doing really funky stuff in Grasshopper. If you model or create these for every component you have and every IdeaStatica parametric template you have, then you can create these links just by adding JSON files to this folder, basically.
And afterward, you can just reuse that.
Exactly. Once you've created that link, this folder can sit anywhere, and you can just link to this folder whenever you want. So you can sort of start to populate this and improve it as you go, basically.
We have some questions, so maybe before jumping to second example, so we can answer the question about the licensing. So we have at company Tekla and IdeaStatica for now. So yeah, in order to use this workflow, you have to buy Rhino, but Rhino is a lifetime access and is pretty cheap. Grasshopper is for free, and the components that you are using are also for free. So it's just going for the Rhino, but compared to other software, it's really cheap, especially that it's a lifetime access to it. There was some question about also PC settings. Is a 32 giga RAM or 64 giga RAM about the workflow, about the graphic cards and the memory? Do you have any recommendation for the computers?
I would recommend 32 gigabytes of RAM. My computer is actually only running 16, but I would recommend 32. Definitely would recommend a graphics card, especially if you're using Tekla, but nothing, nothing more than what you would have if you are using Tekla. And a good processor, obviously, for running the connection calculations. So typically, better processing speed although the better your processor, the quicker that the calculations will run, basically. But nothing ridiculously out of the ordinary if you're already using Tekla, basically.
Yeah. Mikołaj asked about the checkbot following the question previously. So if connection fails, you go back to Tekla, update and rerun again.
So if this is in relation to what I just showed, basically you would change the parameters in StatiCa until you get the connection to work correctly. So you wouldn't actually be modifying anything in Tekla. So you basically you modify the parameters in StatiCa until that connection is working, and then you basically re-import that I guess designed file, and then it will update the parameters in Tekla from there. So you start with like your best guess or your defaults. You design the connections in StatiCa, make sure that they're working, import that back into Grasshopper, and then change your defaults to match the design connection from StatiCa.
Mm-hmm. Okay, we have some more questions, but let's wait to Q&A session at the end so we can answer. Okay, so let's go to next one.
Yes, we'll keep going. I guess we've got a little bit of time. Basically, this next workflow is probably a little bit more complex, but mainly around the Grasshopper generation stuff. I don't know if you have seen this project. It's a really awesome user case that we have on our website, and basically I've been using this a little bit to show off some of the capabilities of Grasshopper. I was not involved in anything, so it's just showing you how you can sort of potentially design or look to use Grasshopper to develop a project similar to this one. So basically what we're going to look at for this one is where we a more, I guess, standardized Grasshopper approach, where you are modeling everything within Grasshopper and using Grasshopper as that source of truth, and then pushing out to StatiCa and Tekla, doing the design, and then coming back and updating that model or updating parameters to get the design to work, or whatnot. So I think let's just jump into it. For those of you that have seen this video on YouTube, this is me when I just woke up and decided to model a connection, but say for the just a connection, a node connection in isolation. This is kind of the precursor to what I'm going to show now, where we're going to model basically every connection in a full structure. And obviously there's some different things that you have to worry about when you're doing this, such as geometric changes and etc. But we'll go through it. So let's start. and basically what I've done here is I've modeled the base structure, and again I've just put some of like I've just grouped the lines, or what I may want to, how I want to group the structure basically on layers in Rhino. And with this structure, we're actually going to use Karamba as like a form finding, do some form finding analysis. It's very basic form finding, but it kind of shows you how you can use Karamba to do some pretty cool stuff. So we just like put a dead load on here, and we take that deformed shape, and we basically flip it to create like that dome arch structure. So you can kind of see that. So we flip that. We get the sort of our arch structure. We keep the grouping obviously, and then we basically create another Karamba model which does the analysis on our form found model basically. So it's quite a cool way to work, especially if your structure is changing very rapidly, and you're wanting to basically not have to copy and paste different files and etc. So we've form found, done some basic form finding, and again we can export that model using SAF. Again, we can use our convert SAF file to turn that into an IOM model. I just turn that off, and instead of applying a template here, basically we're going to model each connection's plates, bolts, and cuts using Grasshopper. So again, I've done some rudimentary grouping of these connections based on the member types, and this script is a little bit more complex and it's pretty messy, but hopefully we should be able to provide the idea of what I'm doing. So basically within each connection, there's a bunch of members, and we sort those around a common plane, and then we start to generate the plates and geometry for each of these connections. So you can kind of see here, I've starting to build up, I guess, the central node, and you can see that this is happening. So I'm using one script to basically generate the geometry for all of the similar connections which I have, and all of these are getting modeled in the same IOM file basically. So you can see here I have a component to create a bulk grid, some cut planes as well. So if I turn the preview on here, you can see like how the bolts are defined, and I'm using logic basically to create all the cuts, all the plate geometry, these stiffening plates in these members, etc. Using Grasshopper and defining the geometry based on cross section sizes, etc. So with a workflow like this, I can basically take any data that I have in the model, such as like cross section sizes, dimensions, and use those to drive my connection design basically. So, and once I've done that, I can inject all that information into my existing connection point. So you can see there the modify connection point component, and again I can deconstruct that, and you can see all the information that's been injected into that file. From there, I can modify my open model, and basically what that does is it updates all those connection points, or all the connection points that I've injected plates and bolts into, saves it into a model that I can use downstream. And then again, I can basically create a connection project using the API as well. So basically, I'll take one of these nodes which I've created because they're quite complex. Can take a while to generate the files. So I'll just just here, I'm just going to take one of them. And maybe you want to do some logical way to figure out which one you might think is going to be the most critical or something, that you can basically make sure that you design that one or something like that. So again, I've connected to the API and I've saved the project, and you can kind of see this connection that comes into StatiCa. So it's fully modeled basically in Grasshopper, etc., with all the bolts, welds. There are some welds missing here. You can basically add those welds, but I won't show going any further with StatiCa. They're just for time.
And
reasons.
the biggest advantage here is when you're going to make any changes in the parametric model, so everything will follow.
Exactly. I think I do show that, hopefully somewhere. And then basically, then the next step is, once you have that open model, again, we can push that to Tekla. So there's a whole bunch of components which allow deconstruction of open model, and we've got a small script here which basically takes all the members and then takes all the plates and cuts, and you can see within like a minute, or actually less, about 10 seconds, you can sort of see the model being populated here. You get those nodes, you get all the member cuts, the plates, and some of the openings. We haven't pushed this to welds yet, and I believe you can't actually generate bolt layouts in Tekla yet. So that may be something we can ask the Tekla guys if they'd be willing to add that. But you can very quickly, from our IOM model, basically deconstruct that model, and you can kind of see here, get the connection points, get all the plates and cuts from that, and basically wire them into the Tekla live link components to generate those. And then, yeah, as Christoph, as you said, the benefit of setting up something like this is when you realize that you've done something not quite right at the start.
Or architect wants to change something.
Yeah, I don't want to speak, ill of architect, but yeah. Or the architect changed something, or loading conditions have changed. So basically, I can go back to the Karamba model. I can change. This is just changing the deformation or the the basic form finding. So you can kind of see how it's moved from that position of where my IOM model is at the moment. And then once I basically redo that, or re-export that SAF model, the IOM model will, or the connections will be basically automatically regenerated.
So we get new parameters for all the members, and all the angles will change, and maybe sizes. So
exactly.
Yeah, we can see that.
Exactly. Yeah. So depending on how you set up your Karamba model, if it's changed the sizes, if the geometry is changing, so you can see here that there was a couple of small issues with the update, but basically within 5 or 10 seconds, that geometry has been re-updated in Tekla. So it's basically redone that whole model. You can also export the StatiCa connection file again with the updated loads, etc. as well. So this is like the other workflow, probably the more applicable workflow. It's like being used a lot in practice at the moment, to develop these types of complex connections, etc. So yeah, that's that one as well. So
I think we for some, it's hard to set up everything. We know, we try to not scare you with all these components. It's more about like inspire all of you. We saw some questions about like which software can be connected with Grasshopper. Once I made some of the lists, as you can see right here. So all the major software that you can make calculation has this connection with Grasshopper. All these connections are for free, and you have these connections also to BIM software. Like in maybe most of the projects are used for Tekla, or maybe some of the Revit. Maybe if you're working with the architecture, the ArchiCAD. So there is this connection. And like the first benefit, I would just go to the first example that you showed, that you can create. Okay, maybe it will take some time at the start to create this connection between idea and Tekla. However, afterwards, you can see the benefits when you are going to make some changes. Before, I just made also some just really simple videos how the Karamba works. For those who are interested, Karamba is really great tool. If you are especially in the preliminary design, you can see if you're just making load changes, you can see how all the cross section, how fast Karamba is after changing some loads, adding with the slider, you can see that cross section are changing and making checks every single time you make these changes. And we can see also this apply with all the deformation in Tekla. So this is really something cool to see. And today Nathan showed this workflow. Like you can we have this centralized Grasshopper model, and you can just seamlessly send it to Tekla, to Karamba, if you have some changes, to StatiCa again. And I know that sometimes we have lots of simplifications in our model, but this is also where Grasshopper shines, because you can have one master model in your Grasshopper and make some tweaks and send a little bit simplified model to Idea StatiCa, or maybe something more detailed into Tekla. So it's not just connected the same structure with the members and all the connections are going. You can also make some simplification, make some eccentricity, and send different information to Tekla and StatiCa, and this is what gives you the biggest advantage. So Nathan, thanks for that presentation. We'll go in 3 minutes into Q&A session. I will just so we will come back to you for that one. I'm going to summarize that, and I'm going to show just 2-3 slides about the upcoming release for the all interested in learning Grasshopper in Tekla. So we are opening doors for the 2nd edition of the Grasshopper in Tekla training. So we will teach you how to build your own tools and tackle the toughest problems when it comes to Tekla structures. So in 2 weeks, we are opening doors for Grasshopper in Tekla. So we have already more than 200 users. And for those interested, we are really recommend to starting. We are also in 2 weeks starting with Grasshopper fundamentals. For those who are starting just would like to learn Grasshopper, feel inspired what you can do. So we are opening doors for that as well. So what is Grasshopper in Tekla training? So this is an online training that opens the door with automating all the boring stuff. All the practical knowledge, I took all the case studies from my work, from my students' work. So we are working on cool examples. We have supporting community, as I said, Tekla super users that are sharing their knowledge and experience, and made by trainers with experience. So in our training, we use different case studies. We have 16-store concrete building. We have also velodrome, bicycle racing arena with steel elements and prefabricated elements. And of course, we have also bridge structures, since I'm a bridge designer. Here in grasshopperintechla.com/agenda, you can find all the information what this training contains. And we are also giving 1 module extra, adding that with how to automate drawings in Tekla, which are conducted by the Greg Olszewski, who created this live link. So for those all interested, in 2 weeks, we are opening doors for all the Grasshopper fundamentals training and Grasshopper in Tekla. So register for the waiting list to get the spot and information about the offer. So next workshop about Tekla and Grasshopper will be on the May 21st in just 1 week. So we will talk with Sebastian Lindholm, who actually created this amazing link with Tekla, and Simon Iverson, who helped him to develop new plugins and components. So that's all for that one. So let's come back. Let's come back to Nathan. So let's go to Q&A session. So I'm going to check what I have start here. Let me see. Håkon he come back to our answer about if we can use this workflow Tekla and idea StatiCa. I think it was question to run it into multiple computers. So Håkon just added that Tekla have something like Tekla model shared service, so you can just share your models, and maybe this can be an option for using that workflow, because just one person have to apply the checkbot from idea StatiCa and upload the changes, and other people can use that one. Question from Zero. Is it possible to make the global finite element method analysis program Edilus software, Italian software? Have you heard about that, Nathan?
I haven't heard about that piece of software myself personally. But yeah, as I kind of said before, any FBA or FEM analysis program can be linked with Checkbot. So yeah, I would encourage you to either try and touch base with them and tell them that you're after this link, and then they can touch base with either myself or the Idea StatiCa team, and we can look at creating a link. We also have an Italian reseller who does ESCO computers, which who does also create a lot of links. So you might want to contact, if you're in Italy, you might want to contact them and ask them, and they might be able to help you as well. Just on the checkbot through Grasshopper, we don't have a checkbot API, so to speak. So we can't interact with checkbot through Grasshopper at the moment. So they're kind of two separate things at the moment. Potentially in the future, that will be something that we can potentially do. But so checkbot and Grasshopper are separate things at the moment.
Yeah, Sergey, Chris, you miss also Lyra and CAD. If you have this information about the connection between Grasshopper and these two software, so just let me know, just reach me out, and I will be eager to test it out. I don't know, Nathan, have you tested? Have you Lyra and SCAD?
I haven't actually. No, those are two other software I haven't tested much.
There are too many softwares in AAC industry. Every single country has own different setups, and I can imagine working Idea StatiCa if you would like to gather all this different information. And I know that you're trying to make the standardized models. However, I think that you are getting lots of questions about the integration with Idea StatiCa and different softwares worldwide.
Yeah, like probably every couple of weeks I get another email about linking Checkbot with a new, another piece of software that I've never heard of. So, but I don't think we've kind of come across one that we haven't been able to create a link with. Yeah, if people are, see the Checkbot and think that it would benefit their workflows, I would encourage to either try and get in contact with that software development company, and then either put them in contact with us, and we can provide them with the information. Typically, it takes like a month, or month to 3 months to have a fully functioning checkbot link. So.
And this is something I really like in Idea Statica, like you building this community and really open to create new connections and really hearing what engineers are looking for. So this is a great attitude. Hadi, is it possible to create a tune the Grasshopper block with code?
I guess it just depends what you mean by tune, but yes, you can basically create those components or any components that you see. You can create them with code, or Chris, I'm guessing in your training as well, you have you show some you know, Python or C# code within Grasshopper.
Yeah, we have dedicated trainings to extend Grasshopper possibilities and add Python and C#. It's more advanced, however, it's really extends possibilities of Grasshopper.
Yeah, exactly.
So yeah, so answering, yeah, you can use Python and C#. Python free, it's in Rhino 8, and C# is available, so you can create also with the text-based programming there. And you, Nathan, you for sure you're using a lot. You're Python or C# team, Nathan?
C#.
Yeah.
But yeah, it's an interesting conversation. But yeah, having to learn more Python now to support the engineering industry, I would say, who love Python.
How do you just write adment instead of using GUI?
Yeah, so maybe I can speak briefly. So basically, the components that you see in Grasshopper, they're literally a wrapper of our API. So the component itself has a couple of lines of code which call our API, and you don't need Grasshopper at all to do that automation. So you can do it in Python or you can do it in C#, just using our API directly. And you could also basically extend a Grasshopper component to do multiple functions within one, by using, as Chris said, like the custom C# components, etc. within Grasshopper. So yeah, so basically the Grasshopper components that you saw today doing functions for ID Statica connection are basically just on top of our API, which is accessible as well.
Let me see. Is it possible to combine Tekla with Tekla through Grasshopper? Grasshopper reads Excel and makes model in Tekla. I can answer that. Of course, it's possible. This is one of the biggest benefits, that Grasshopper can integrate with different software, and of course, Excel is one of them. And usually, I can see also my students are using Excel a lot to import data, for example, for building the industry halls, like if they have some parameters about center distance between columns, heights, some bracings, and you can just import that and build geometry in Tekla through Excel. Just tweaking some with parameters, as Nathan tweaked a little bit with parameters between Tekla and Idea Statica, so you can also do the same with Excel and Tekla. So as I saw you some of your comments on the chat. So yeah, it's possible to join the waiting list for the Grasshopper Foundation. We are starting recruitment in just two weeks, so we really recommend that one. Okay, I cannot see more. If you have more questions, so we are going to read the last here, and we are on the time. So thank you, Nathan, again for showing. Thank you for work and just trying this proof of concept. I think we inspired some of the engineers working with Tekla and Idea Statica that showed new ways of working, and hope it will be used and developed further.
Yeah,
maybe
for
to
sure.
some vanilla Grasshopper idea StatiCa components.
Yeah, exactly. Awesome. Yeah, thanks for having me again. Always a pleasure. And yeah, feel free to get in touch on our Idea Statica GitHub, or get in touch with me on LinkedIn, or whatever. So always up for discussions on these types of topics and people trying to push things further. So
Perfect. And see you next week in Vienna, right?
yeah, looking forward to it.
And maybe next year we can do another workshop about connecting Tekla idea Statica for concrete structures.
Yeah, we'll see.
I will.
Sounds
I
good.
will make it. I will make it on the list. Thank you, Nathan. Again, I appreciate your support on that. And yeah, good luck with your further developments. Bye bye.
Awesome. Thanks, Chris. Bye.